Okay, guys, let's see. Group 16. The other day we discussed about group 15. Now let's see. Acha, group 15 mein I think we left with acids. Class ka acid part reh gaya tha shayad. This is one part I told you to just go through it. What are the types of acids we have? Okay. So वो एक part आप check कर लेना. Let me start with group 16. In group 16, beta, these are called chalcogens. Chalcogens means they are ore forming elements. So something like MXOY, MXSY, ऐसे रहेंगे. The general nature of these elements, if you take oxygen and sulfur are non-metals, selenium and tellurium are metalloids, polonium is radioactive metal. If you see oxygen, oxygen exists as a dimer and it is a gas at room temperature. Okay. Well, oxygen will have very strong p-pi bonding. So if you see the overlapping tendency, 2p pi is greater than 2p pi 3d pi and 2p pi 3p pi and 3p. So 3p overlapping is relatively not very good as compared to that of others. Correct. So that makes it that oxygen to have high ability to form p-pi bonds. So sulfur, selenium, tellurium, they are usually existing as solids, while polonium also exists as a metallic solid. Correct. Most of the forms of sulfur, unless it is at very high temperature, they exist in S8 form. Okay. See the size now. Atomic size wise, if you look at it, polonium will have the biggest size and it's a very regular trend that is increasing down the group. Ionization is also a regular trend which is decreasing down the group because yahan par inert pair effect isn't very observed in the case of group 16. There are very few cases which can explain via inert pair effect. Otherwise, it does not influence much on the ionization. This is an important order, electron affinity. Oxygen will have least electron affinity as compared to the other elements. One thing, if we take oxygen and add an electron to it, and it becomes O minus, correct? Just like fluorine, the electronic repulsions will be more in oxygen. Although it releases energy, it is not as much as that of these elements, these four elements, correct? So oxygen has the least electron affinity, clear? And electron affinity, first electron affinity is negative, while the second electron affinity is always positive for all the elements. Okay. While oxygen and sulfur, if you compare, oxygen ka positive value zyada rahega sulfur se. ठीक है? So therefore we can say sulfur ka, even if you take the overall negative ability, matlab taking 2 electrons, sulfur is better than oxygen. Clear everybody? That is about electron affinity. Electronegativity wise, if you look at it, oxygen is the second best electronegative element, you know, after fluorine, and the value is 3.5. And oxygen, then sulfur, selenium, tellurium, polonium, which is in quite an order. Now, melting point and boiling point get influenced by the inert pair effect, where you can see polonium will have slightly less melting and boiling point because of non-participation of NS electrons. And that's what we call it as inert pair effect. Clear everybody? Now that is about melting and boiling point. Now in this group, you will see oxidation state, correct? Mainly for oxygen, it ranges from -2 to +2, which includes -0.5 also. Few exceptional ones are here where oxygen showcases +2, +1. This is oxy difluoride, oxyfluoride, peroxide, superoxide. These are the names of those respective oxygens. Sulfur can show from -2 to +6. Okay. And you would see S2Cl2 where sulfur is also showing +1. SF4 where it has +4, SCl2 +2, +6 and -2. These are all the examples where they show various oxidation states. Selenium also shows almost all the similar, oxidation states, while tellurium does not have -2. So tellurium shows 0, +2, +4, +6, while polonium shows +2 and +4 only, correct? 0 also. So 0, +2, +4 only. +6 is not exhibited because of inert pair effect. Clear with oxidation states?
एक मिनट आप
नेक्स्ट
ऊपर जाओगे एक बार वापस देखने दोगे?
हाँ बेटा देखो।
तो मुझे सेलेनियम का +6 वाला नहीं, एक बार इनर्ट पर इफेक्ट में कैसे हुआ मुझे समझ में नहीं, बताओगे क्या बस? और अगर सेलेनियम में +6 नहीं सर, इन एसई हैव रिटन +6 नहीं होता है, बट टीई में +6 कैसे होता है फिर?
किसमें बेटा? सिर्फ पोलोनियम में नहीं हो रहा है ना?
ओह प्लस पोलोनियम, आई एम सॉरी, मुझे वो सेलेनियम के आगे +6 पे क्रॉस किया, सॉरी।
So this is polonium has +6, which cannot occur for polonium. Okay. Next, see the stability of -2 oxidation decreases क्योंकि metallic nature बढ़ते जा रहा है as you go down the group, and +6 oxidation state will also decrease because inert pair effect exhibit करना start हो जाएगा, and +4 is the only stability which increases down the group. Okay, so most of them exhibit +4 very easily as you go down the group. Now, if you see the covalency is the maximum number of bonds an element can form. For oxygen, if you take oxygen can make 4 bonds, while polonium can also make 4 bonds because of inert pair effect. Rest all can make maximum up to 6 bonds. For example, if you take oxygen ना बेटा, HO- में देखो, इसमें एक ही कोवेलेंट बॉन्ड बना है. H2O में 2 कोवेलेंट बॉन्ड बने हुए हैं. H3O+ there are 3 covalent bonds. But see, this is an example called as basic barium nitrate. So where we have Be4O with NO3 6 times. It is a complex where you can see oxygen is, exhibiting exhibiting 4 covalency, where you can see there is one dative bond here, one dative bond here, one sigma bond here, simple covalent bond on this side. So octet भी complete हो रहा है, and it is letting all 4 electrons participate, and it's a tetrahedral structure on this oxygen here. Rest all nitro groups are surrounding between berylliums like this. ऐसे 6 berylliums के बीच में nitro groups present है. This is called basic beryllium nitrate. So asked in JEE advanced once, so please learn it. Basic barium nitrate will have oxygen with maximum covalency 4. Clear beta? Next, see the hydrides. These group elements, all of them will form hydrides. Okay. If you take water is in liquid state. H2S, H2SC, H2T, they are in gaseous state. While polonium is radioactive, correct? So we will not discuss much about it, like what state it is, but only for this you can see water is in liquid state, rest all are gases. See, bond dissociation energy, it's naturally always going to decrease down the group because the size of the atom increases, so it is easy to break. So always compare the size of atoms. So size of atom increases, okay, hence it will decrease down the group. Next, Ka value, you see the acidic nature, correct? Down the group, all hydrides, right from 13, 14, 15, 16, 17, all of these group elements, if you compare their hydrides, their Ka value will always increase. Okay. Next, if you check the thermal stability, because the bond energy is decreasing down the group, so thermal stability will also decrease down the group. Right. Boiling point is an important case here, that although water has low molar mass, because of very strong hydrogen bonding, it would have higher boiling point compared to others, H2T, H2SC, and H2S. Clear, everyone? Next, see melting point. If we talk about melting point, H2O again will have very strong melting point compared to H2T, H2SE, and H2S. Bond angle, if you compare bond angle, water has 1045 degrees because of lone pair repulsions. It won't exhibit 109 degrees. But then if you see H2S upon H2TE, the bond angle is very close to 90. And this is because all of these are unhybridized. Let me put that. All these three are unhybridized orbitals. And since they are unhybridized, their bond angle, would be very close to 90. And that is what we come across through Draco's rule. Next, see the reducing nature. Down the group, if you go, the reducing nature increases, which means ability to release nascent hydrogens increases. So this will give away nascent hydrogens more easily. Okay, increases. So they will easily give nascent hydrogens. So reducing nature always increases. It is for all the group hydrides, beta, not just for group 16. ये सबके लिए होता है. Now see about oxides. Now when it comes to oxides, two types of oxides are normally formed for this. One is EO2 and the other one is EO3. EO2 type of oxides, if you look at it, that is SO2 and SeO2. Those are covalent oxides. Well, if you see this TeO2 and PoO2, they are ionic oxides. They will exist in ionic bonds. And all oxides are acidic except tellurium and polonium. If you see sulfur dioxide, if you add it to water, you will get H2SO3 acid. SeO2, you will get H2SeO3, which is selenic acid. TeO2 and PoO2 especially act like amphoteric oxides. This is radioactive in nature, so we don't discuss much about polonium, but TeO2 is amphoteric is an important example. Clear, everybody? Next, see beta. Sulfur can exhibit, pi bonds easily because oxygen can make overlapping to the empty d orbitals. So therefore, it can exhibit p pi and d pi better. So therefore, sulfur dioxide can exist as only double bonds. But selenium dioxide, on the other hand, will, although they have p pi d pi bonds, correct? It will increase their bond strength by making, polymeric forms. Right? So they will make polymeric forms and try to increase their bond strength. So that's why selenium will start becoming a polymer, and that's why SeO2 exists like a solid form. Okay. Selenium reactions, we have seen it earlier, selenium dioxide reactions. Mainly selenium dioxide, we use it when we have to oxidize aldehydes or alkenes. See, aldehydes are ketones. On the alpha position, selenium will make it to oxidize to, again, carbonyl group. You will get this as, C double bond O in the alpha position. While if it is an alkene, for an alkene, SeO2 will react and give an allylic substitution of OH. So it is oxidizing alkene towards alcohol, correct? By allylic substitution. Clear on that, everybody? Any doubts so far? Right. Now see the acidic strength. Down the group for oxides, always acidic strength decreases, basic strength increases. For entire group, right from group 1 towards, if you come to group 17, always oxides, basic character increases down the group and acidic character decreases down the group. Same thing, reducing agent, if you see, the reducing character for SO2 is better as compared to others, while oxidizing character is much better for TeO2, right, as compared to that of SO2 or SeO2. Now TeO2, because it does not make very strong double bond formation with oxygen, and on heating, it will easily give tellurium and oxygen. So this will have quite a similar property as that of how Ag2O or mercury behaves. Like if you take Ag2O, you heat it for a very nominal heat temperature, it will release out oxygen. Okay, same thing happens with tellurium also. Clear? Okay. Well, even if it forms simple oxide also, that oxide will again convert back to tellurium. So easy to get tellurium there. Now see EO3. If you see EO3, SO3, SCO3 and TO3 are formed. And because they are already at their highest oxidation state of +6, +6 and +6, so therefore they do not act like reducing agent, they can only oxidize. And just like oxidizing behavior for 2 oxygens, here also oxidizing behavior is very strong for 3 oxygens. Since sulfur and oxygen bond is much stronger, it is difficult to break, and tellurium breaks very easily to act like an oxidizing agent. All of these 3 are acids, and if you add it to water, you will get H2SO4, H2SCO4 and H6TeO4. Okay. See here, when you talk about SO3 for example, आप ऐसे सोचो कि सारे 3 OH तो पहले से ही थे, 3 oxygens तो पहले से ही थे, and on hydrolysis another 3 will come. But these many OH groups are unstable around sulfur, so they will dehydrate at least 2 of them. So 2 of them will get dehydrated. So it will exist like H2SO4. And the same will happen with H2SeO4. But tellurium does not make any strong double bond character. And also the size of tellurium is very big. So therefore, it can have all 6 OH groups without much of repulsion. And this is important, that telluric acid, will not have any double bonds present in it. It will be simply H6TeO6, that is telluric acid. Clear, everybody? Hey guys, any doubts so far? Most of you look very silent today.
No, sir.
Yes. Okay.
Fast, slow job, you said.
You can stop me, beta, if you're not going anywhere, right?
No,
okay, don't worry.
Everything is too fast, sir. वो सुबह से class लिए भी time थोड़ा सा slow कर सकते
हैं. I'm totally with you. I can go slow. Don't worry. Okay. You please tell me if I'm going fast. Okay, I can immediately stop. See. Now let's talk about halides. These group elements also form halides. Oxygen भी halides बनाता है. Sulfur बनाता है. Selenium, tellurium and polonium. This entire table is given in NCERT बेटा. अब इसको कैसे रटे ये तो मुश्किल है, सब कुछ रटना मुश्किल है. मैं एक थोड़ा सा आइडिया दे देता हूँ कैसे रटने. देखो, ऑक्सीजन with halides, okay, only EX2 is formed only with fluorine and chlorine. OF2 and OCl2 ये दो ही बना सकता है. OBr2 OI2 बनता नहीं है because they will have more repulsions between the atoms. इतना closely वो नहीं आ सकते हैं because of van der Waals repulsions. They do not exist. Next, XeO2 only is exhibited by O2F2, right? So this is the oxides. Now coming to sulfur. Sulfur almost सारे exhibit करता है. And when it comes to EX6, अब ये याद करने का तरीका देखो. EX6 सिर्फ और सिर्फ फ्लोरीन ही बना सकता है. क्लोरीन के साथ नहीं बन सकता है. ब्रोमीन, आयोडीन ये नहीं बन सकता. So sulfur will form selenium, tellurium. Polonium को भूल जाओ because +6 वो exhibit ही नहीं करता है ना. Next, sulfur. If you see EX4 again, फ्लोरीन तक बना यहाँ पे फ्लोरीन और क्लोरीन भी बन जाएगा. Again bromine and iodine not so much. And EX2, F2 and Cl2 is formed, not Br2 and I2. But here you can see one step ahead, Br2 भी यहाँ पे फॉर्म करने लग गया. SeF2, SeCl2 and S2Br2. Clear? Iodides देखो ज्यादा कोई भी फॉर्म नहीं हुए, कोई भी फॉर्म नहीं हुए for sulfur. ठीक है? And all of these are coming with respect to the bond dissociation energy बेटा. जिसका bond dissociation energy ज्यादा है for formation, they usually form. Otherwise, they usually undergo disproportionation and not stable. Clear? Now, Coming to selenium. Selenium can show FeF6 and now as the size is increasing, X4 में वो फ्लोरीन, क्लोरीन, ब्रोमीन तीनों दिखाएगा. This is an important area. बस इसी पे क्वेश्चन पूछा गया है पहले में. That selenium does not form X2. X2 वाले कंपाउंड्स वो नहीं फॉर्म करता है. Whether it is SCF2, SCCl2 और SCBr2. इसको कहते हैं middle row anomaly. There is not much of an explanation given anywhere on this. So I'll just put it here simply as this is middle row anomaly. That's it. Apart of that, as you come towards E2X2, only chlorine and bromine are identified to form. Tellurium TeF6 is formed. Chlorine, bromine, iodide are formed here. Chlorine and bromine be form karta hai. I didn't write it, but bromine is also there. TeBr2 and TeI2 is formed. And Te2X2 is not formed here. Polonium, chloride, iodide, bromides are formed. Chloride, bromide are formed here. Iodide are also formed here, okay, but not very well observed. But other than that, E2X2 are not formed at all, okay. Now, in all of this, if you observe, hexafluorides are well known out of all of this, in which SF6 is inert and very heavy gas. SF6 is gaseous because ये चारों तरफ से इसका कोई भी dipole moment नहीं रहेगा और resultant dipole moment is 0. Hence it is a non-polar molecule, so it will only exhibit van der Waals forces of attraction. Therefore, strong attractive forces नहीं रहेंगे. Even though it is very heavy, it exists in the gaseous state. Correct? That's why it is called as the heavy gas. And SF6 does not undergo hydrolysis due to the steric repulsions on, steric hindrance on sulfur. From all the 6 sides, fluorine is surrounding it, so sulfur does not give hydrolysis due to its steric factor. Next, if you see tellurium, TeF6 undergoes hydrolysis to give H6TeO6, which is telluric acid. So 2EF6 को hydrolyze कर दो, it will give H6TeO6 plus HF. If you see the rate of hydrolysis, definitely TeF6 will be much better because it can easily be attacked by water because of its bigger size and compared to that of SCF6 and compared to that of SF6. Now, let us talk about SF4. SF4 में problem नहीं है because it is not way highly crowded, so water, it can undergo hydrolysis easily with SF4. It will give H2SO3 and HF. So that's how SF will undergo hydrolysis. Next, C, monohalides exist as dimers and undergoes disproportionation for all the compounds, whether it is selenium, tellurium or polonium. Sulfur. Se2Cl2, selenium, will disproportionate as Se and SeCl4. Similarly, S2Cl2 of sulfur will become S and SCl4. And SCF2 of sulfur will also become S and SF4. So, इस तरह से वो dimers, the dimer forms will undergo disproportionation in case of sulfur and selenium. Clear, everybody? Right. Now, these are generic properties we have studied. Now, let's see compound by compound. The first compound is all about heating. ऑक्सीजन, ये अपने हीटिंग इफेक्ट्स में पढ़ा होगा जहां पे भी ऑक्सीजन आ रहा है. लास्ट क्लास में हमने हीटिंग इफेक्ट्स पढ़ा है जिसमें नाइट्रोजन आ रहा था. नाउ इन दिस केस ऑक्सीजन इज कमिंग. सी, PbO2, MnO2, Pb3O4, ये सारे जितने भी है, when you heat it, they will all give away oxygen, leaving behind their respective oxides, simple oxides. Okay. And apart of this, if you heat less electropositive elements, अभी मैंने बताया था in Ellingham diagram, silver and mercury will be much closer, correct? That is around 50 to 100 degrees 50 to 100 degrees temperature mein hi, if you heat silver or mercuric oxides, you know, easily they will cross over delta G is equal to delta G positive की तरफ चले जाएंगे, which means their oxides are unstable. They will immediately give away oxygen. Clear? And heating peroxides like barium peroxide, hydrogen peroxide, if you heat them, they will give away oxygen. Now, if you are extracting this oxygen from barium peroxide, that is called Brin's process. It is called Brin's process. Once it was asked sometime in a JEE mains exam, so learn it. What is Brin's process? A part of that, peroxide will be used. Peroxide will give oxygen at a much faster rate if you use MnO2, which will act like the oxidizing agent here. Okay, sorry, which will act like a catalyst. My mistake. It will act like a catalyst and give away O2. Next, heating salts. Like if you check KMnO4, it will become K2MnO4, MnO2 and release O2. K2Cr2O7 on heating, Cr2O3, K2Cr4 and O2. KClO3, KCl plus O2. PbNO3 twice, and metals like this, all of these metals, which are nitrate metals, on heating will give you PbO, NO2 plus O2. If you take KNO3 also, you will see KNO2 plus O2 is forming. CaOCl2 in the presence of cobalt chloride. This is cobalt chloride. That would also give calcium chloride and oxygen. So all of these are heating effects, beta. ये जितने भी questions आप heating effects में पहले पढ़े होंगे, ये सब oxygen के लिए. इससे कल last chapter में हमने पढ़ा वो सब nitrogen के लिए था. How to get N2. Okay. Next, heating few salts in sulfuric acid. For example, if you take KMnO4, add it to concentrated H2SO4. First, we will get Mn2O7 because ये completely dehydrate कर देता है, and then K2SO4 plus O2 and some part of H2SO4 will undergo reduction. So that's how we will get
this reaction क्या कि कहाँ पे Mn2O7 आ रहा है, कहाँ पे MnO2 निकल रहा है, like that.
Only on heating, right? If you strictly ask me, these two are very important because directly they are given in NCERT and very frequently asked. Got it, beta? Apart of it, in salt hydrolysis, we have seen that most of them which forms nitrates, they will always give NO2 plus O2 as a combination. Okay? बस इतना याद कर लो. ये बहुत ही ज्यादा less prominent है in terms of reactions asked. Correct? So don't worry about these reactions. हाँ, इतना याद करो. हाँ, इतना याद करो कि ये जो concentrated H2SO4 यूज करते हैं तो उनके highest oxidation state के oxides में ही रहेगा ये. So this has to be highest oxidation state. This also has to be highest oxidation state. Clear? So manganese does not exhibit something like highest इसी में बनाता है Mn2O7 and chromium will make CrO3. ये चैतन्य?
Yes, सर आपके नोट्स में सारी चीजें कवर्ड है ना, मतलब आपके नोट्स से एनसीईआरटी पढ़ लिया बस हो गया ना, और कुछ पढ़ने की जरूरत नहीं है.
हाँ बेटा, पहला मैं 10 बार बोल चुका हूँ.
सर नहीं, मेरा कल का सर पेपर्स में बहुत ऐसे एडवांस क्वेश्चन आए थे, बिल्कुल नहीं हिल रहे थे सर. क्या MT6 में भी
bring specific questions if you have it. Correct?
Yes,
I'll help you out.
I'm sorry,
but
sir,
otherwise,
yes sir.
No. Otherwise, it's okay. You just go with this first. ठीक है? Extra जो भी है ना, extra थोड़ा पढ़ाना है मुझे, but वो अभी नहीं चाहिए अब. When I see mains is done, correct? Then considering all of this is, आपको इतना comfortable है, ये comfort है कि हाँ इतना तो मैं समझ सकता हूँ. Then we'll do those extra questions needed. Okay? Next, see PbO2. PbO2 with concentrated H2SO4 can form PbSO4 as a precipitate. It will give SO2 and O2. MnO2 also in concentrated H2SO4 will get oxidized here, reducing sulfur, and some part of oxygen is coming out. So these are heating the sulfuric salts. I mean sulfuric in the presence of sulfuric acid. In the large scale industry, then electrolysis of water is the best way to get oxygen. Okay. And liquefaction and distillation. Yesterday we have seen the same thing for nitrogen also, last class. नाइट्रोजन के लिए भी यही बेस्ट मेथड होता है. नाइट्रोजन का बॉइलिंग पॉइंट थोड़ा कम होता है, 87 केल्विन्स, करेक्ट, while oxygen is at 93 kelvins. So oxygen बाद में आता है after nitrogen. So idea is to compress below critical temperature and then liquefy. See the properties of oxygen. Okay. See, O2 is colorless and paramagnetic. Why paramagnetic? You can just recall it from the molecular orbital theory. So if you write the molecular orbitals for oxygen, you know that pi star will have one, pi star 2px will have one electron, pi star 2py will have one electron. And liquid and solid form of oxygen are relatively blue. Okay. अब ऑक्सीजन में ये थोड़ा ब्लू कलर इसलिए आ रहा है कि देखो ये जो two unpaired electrons है, it will act like a triplet form. Triplet means what, beta? Sorry. Triplet is what? Triplet means the total spin. If you see the total spin, 2s plus 1 आप check करोगे, तो total spin here, sorry, here. You can see the total spin here is there are two half spins into 2. That is the total spin. So 2 into half spin into 2 plus 1 is coming out to be 3. So this is the nature of that compound. So we call it as a triplet oxygen. If you are getting total spin as 3, we call it as triplet molecule. So usually oxygen exists as triplet molecule at room temperature. Okay, but if there is any light being, अगर कोई light पड़ता है उसके ऊपर, so when it absorbs light, it will go through this transition. तो पहले ये triplet थोड़ा singlet form में हो जाता है, correct? It will start becoming singlet form, and again changes into this triplet form with changing the spin, correct? Clear? So here it will undergo spin forbidden. Through spin forbidden, there is an transition of electron within them, and इसके लिए because of that it will start showing slight lightish blue color. So I hope you guys have idea now. So आपको इतना अगर क्वेश्चन कहीं आया है ऐसा तो आप ये याद करना कि first it starts from triplet, converts to singlet, and from singlet again it comes back to triplet form. ठीक है, and this goes via मतलब ये फिर से इस तरफ आ जाएगा ऐसे. That's how triplet becomes singlet, singlet will become triplet, and keep happening. Next, see, O2 reacts with most of the metals and non-metals, but inert towards inert metals. There are 4 inert metals. Last time also we discussed that platinum, rhodium, gold, and iridium. These are called the noble inert metals. Okay, and O2 is also inert towards noble gases. Clear? So it does not react directly with these metals. Otherwise, rest all elements will react with oxygen directly. So SO2 plus half O2 will give V2O5. We know that this is the contact process to form SO3. So here O2 is used. Next, HCl plus O2 will give you Cl2 plus H2O. Cl2, this is also used as the Cl2 preparation where O2 is being used, and this is called Deacon's process. Other than that, there are a lot of uses of O2. We have seen that in cumene process in organic, where we see cumene is being treated with O2 and heated. तो हम लोग को पहले मिलता है cumene hydroperoxide. So there is an peroxy linkage that comes between carbon and hydrogen here. And then on hydrolysis, this bond will break. Phenyl will migrate here and makes this as a keto form, and phenols will form here. and this is the preparation. This is one of the preparations of phenols. You just recall that. You see, this is the one of the preparation for phenols. Okay. So note, these are the cases of reaction of O2. Let's see about ozone. Ozone is mainly prepared by silent arc discharge. Arc discharge matlab kya hai? You have to supply, basically you have to conduct through electricity, right? Heat silent as in you should not use much heat, got it? There should not be much of a heat, only electrical arc should be used. So through electrical arc, oxygen can be converted into O3. This is a mechanism. O2 will convert into two nascent oxygens, and 2 moles of O2 will combine with, 1 mole. 1 mole of O2 will combine with, 3 moles. 2 moles. 2 moles of O2 combines with this two nascent oxygens to give 2 moles of O3. So if you write it as the overall reaction, so we can say 3 moles of O2 is giving 2 moles of O2. अच्छा देखो बेटा, यहाँ पे 3 moles है, यहाँ पे 2 moles है, which means the entropy is decreasing. Next, this delta H formation for this reaction is positive. Okay, for this reaction is positive, and delta H will be equal to delta H minus T delta S, and delta S is negative, which makes this entire thing as positive. और ये भी positive है. So delta G is positive for this forward reaction. Clear? Which means thermodynamically it should not form. Thermodynamically it should not form. That's why we are using silent arc method. And the percentage formation is also very less. So if I take 100% oxygen, maybe I will get some 90% oxygen max. Rest 10% ozone will be formed. And we have to instantly isolate this ozone by rapidly decreasing temperature. Okay, otherwise this gas is called, the mixture is called ozonized oxygen. This is called ozonized oxygen. Okay, if you recall, yeah beta.
So which compound has a lower freezing point, oxygen or ozone? O2 or O3? So which has a lower freezing point, O2 or O3?
O2. Okay.
Okay, so मतलब isolate करने के लिए you need to freeze ozonized oxygen first, or just really cool it down. Freeze and cool it down.
Yes.
So yes,
see what we do.
Yes, cool it down.
See how we'll do it. I tell you. The minute we use this in the reactor, ये एक reactor जैसा होता है, ये silent arc करने वाला. उस reactor में जैसे ही एक बार ओजोनाइज हो जाए, immediately we add turpentine oil. Okay, and cool it down. Immediately cool it down. So what happens? Turpentine oil will completely absorb ozone. Got it? That is the characteristic of turpentine oil. So बाकी जो gaseous state में बचा रहेगा वो सिर्फ ऑक्सीजन रहेगा. समझा बेटा? अभी जब जैसे आप कूल करोगे तो turpentine oil will convert, I mean that will starting to freeze and it is already in a liquid state. So ऑक्सीजन को हम लोग separate कर देते हैं. Chaitanya, are you with me, beta?
Yes, sir.
And once you separate that oxygen out, now again we will remove it from turpentine oil, correct? Just by heating it. Slightly heat करेंगे तो ओजोन सेपरेट हो जाएगा, टर्पेंटाइन ऑयल में से ओजोन बाहर आ जाएगा. ओके, ओजोन को हाई टेम्परेचर पे रख नहीं सकते. थोड़ा भी हाई टेम्परेचर दोगे तो यू कैन सी दिस इज हाईली स्पॉन्टेनियस इन द बैकवर्ड रिएक्शन. करेक्ट? सो इट विल, थोड़ा भी रूम टेम्परेचर पे भी लेके आओगे ओजोन को, so it will start moving backwards towards oxygen.
Okay, thank you, sir.
I hope you understood, beta. Yeah.
Yes, sir.
Right. Next, see what are the properties here now. Ozone exists as pale blue color in gaseous state, dark blue color in liquid state, violet black in solid state. Okay. As much as NCERT, these two things are given. Like in gaseous state, it is pale blue. In liquid state, it is dark blue. Next, O3 is thermodynamically unstable with respect to O2, hence easily decomposes. Like I said, O3 can give away O2. या ऐसा भी हो सकता है, O3 को आप ऐसे सोच सकते हो कि O3 is giving O2 plus nascent oxygen out. So this nascent oxygen will give bleaching effect also, and all nascent oxygens will act like very strong oxidizing agents. Hence, O3 is one of the strongest oxidizing agents, beta. Now, these are standard oxidizing reactions. We have seen it earlier also. Let me show you. O3, if you react with PbS, देखो सल्फर -2 ऑक्सीडेशन स्टेट पे है, वो पूरा का पूरा ऑक्सीडाइज होकर SO4 में कन्वर्ट हो जाएगा. H2s, sulfur is at -2, that will convert into colloidal sulfur, water and O2. NO2 minus will convert into NO3 minus. ASO3 3 minus will become ASO4 3 minus. SO3 2 minus, which is at +4, will become +6 oxidation state, oxidizing it. Iron will oxidize to +3. HCl also will get oxidized, where chlorine is getting oxidized to Cl2. Okay. These are all oxidizing reactions. Now, other than that, manganate, K2MnO4 is manganate on reaction with O2, will oxidize to permanganate. So it will become KMnO4 plus O2 and KOH. O3 oxidizes I- to I2 in the neutral form, but in basic form, it will take I-2, IO3- and IO4-. So strong oxidizing agent in basic nature. So O3 is a strong. Yeah, beta.
Which is a major product in IO3- and IO4-? या फिर दोनों 50-50 होते हैं?
Usually this is always formed major. Okay. I'll show you in a reaction now. Got it? See this reaction. Here it is. O3, got it? If you use with non-metals like sulfur, sulfur will get oxidized to H2SO4. Phosphorus will give H3PO4. Iodine will become HiO3. Got it? So you can see that ये HiO4 में oxidize नहीं होता है, and that is the same issue here also. So like I said, IO4- formed in basic medium is very less, and IO3- is a major product. Here, major. Okay, but and another reaction you can see, when you react with I2 dry, it forms a compound called I4O9. Very, very important compound. I4O9 का structure कैसे होता है बेटा? It is an ionically bonded I3 plus with IO3 overall 3-. Got it? This will form some kind of an FCC structure. Got it? A crystalline form where I3 plus is ionically bonded with IO3-. Chaitanya, clear beta? So major product is always IO3-.
नहीं समझ में reaction में करने समझता हूँ.
No. It will I2 will oxidize with O3 till it forms something called I4O9. Okay.
So I4O9 तो highly unstable होता है ना?
No, the form is this beta. Yeah, I3 plus it is ionically bonded with IO3 के 3-. इस तरह से. Okay. So ये ionically bonded है. Salt की तरह सोचो. Okay.
Okay.
Next. O3 if you react with KOH, इसमें क्या होगा? This oxygen is getting reduced by taking an electron, and ये वाले oxygen को ये oxidize कर रहा है, making it O2. So this the ozone वाला oxygen is taking electron from this oxygen, और वो oxygen O2 में convert हो रहा है. So O3- जो फॉर्म किया वो पोटेशियम के साथ आयनिकली बॉन्ड करके it will make a compound KO3, and KO3 is orange red precipitate. And here oxygen is showing an oxidation state of -1/3. Have you understood that?
Yes, sir, got it.
राइट, क्योंकि ये ओजोन से फॉर्म किया है, दिस इज कॉल्ड पोटेशियम ओजोनाइड, called potassium ozonide. Now that is clear everybody. Okay. और पोटेशियम ओजोनाइड को मैंने यहाँ पे रिएक्शन लिखना भूल गया, just put that reaction also. KO3 जो फॉर्म किया है उसको स्लाइटली हीट भी कर दोगे, so it will again convert into KO2. Okay, and KO2 तो आपको पता है ना, KO2 is what? Superoxide. It will convert into superoxide. Clear everybody? And if you just recall, just like superoxide were more stable with potassium, rubidium and cesium, similarly ozonides will also be stable with cesium, more in cesium, with rubidium, and then KO3. This is how the stability varies. So इतना पार्ट है ना बेटा, इसमें ये वाला सेक्शन थोड़ा important है as much as mains and advanced is concerned. Ozone के reactions, okay? They are very specific reactions. Clear all of you?
Yes.
Now let's see about sulfur. Sulfur has many allotropic forms. That is because of its good catenating ability. Okay. One part is orthorhombic, or also known as the alpha sulfur. And this is the most thermodynamically stable allotrope. Okay. And delta H of formation for that, we usually take it as delta H of formation of this S8 form is assumed to be 0. It is usually found in volcanic areas and it will come out as yellow color crystals. Okay. And this sulfur is insoluble in water, but it is soluble in CS2. So which means it is more soluble in non-polar solvents. Now usually lab में कैसे prepare करते हैं? It is prepared by dissolving roll sulfur. Okay. Roll sulfur means, you know, if you take sulfur from aqueous solution and dry it, उसको ड्राई कर दोगे और उसको शीट्स की तरह कन्वर्ट करोगे, उसको कहेंगे रोल सल्फर. सो यूजुअली एक्वस सॉल्यूशन से जो सल्फर निकालते हैं हम लोग, उसको रोल्स की तरह कन्वर्ट करके रखते हैं, एंड दैट इज कॉल्ड रोल सल्फर. ऐसे. सो यू टेक दैट रोल सल्फर, okay, which is like the raw material for sulfur, and add it to CS2 and slowly evaporate. Okay, and अभी CS2 धीरे धीरे evaporate होने लगेगा. So it will first convert into beta sulfur above 369 kelvins. Okay, it will first convert into beta sulfur at around 369 kelvins. अब 369 के ऊपर जाओगे, correct? Up to this point it is in equilibrium. Okay, so 369 के ऊपर जाओगे तो बीटा फॉर्म चेंज हो जाएगा. वो थोड़ा सा अल्फा फॉर्म में आ सकता है या थोड़ा सा और कोई फॉर्म में जा सकता है, वो आगे पढ़ेंगे कौन से फॉर्म में जाएगा. Okay, but this is the temperature where beta sulfur is usually formed. Okay, so usually so how it is formed, let's see. First, if you melt alpha sulfur in a dish and cooling it down till the crest, okay, crest is formed. मतलब अब पहले मेल्ट कर दो अल्फा सल्फर को. देखो यहाँ पे क्या बन रहा है, at around 369 degrees we will have alpha sulfur forming. Along with that there is small bit of beta sulfur which is at equilibrium, है ना. मतलब ये इक्विलिब्रियम तक आज मतलब ये अभी अल्फा सल्फर मेल्टिंग पॉइंट, अल्फा सल्फर को मेल्ट किया हुआ है हमने, तो वो बीटा सल्फर के साथ इक्विलिब्रियम पे है. And the same thing I have written here, melting alpha sulfur in a dish and then cooling it down till the crest is formed. तो ये जो crest form करता है ना ऊपर, you cool it down till the crest is formed. You make 2 holes here. Okay, in the crest you make small holes here and leave out rest of the liquid and pour it out. ये जितना भी liquid है उसको निकाल दो. अब ये जो crest form की है ना, that crest form will be more needle shaped inside. Okay, inside it will be more needle shaped like this. इस तरह से needle shaped रहेगा. Correct? And this needle shaped form is what we call it as the beta or monoclinic sulfur. Monoclinic sulfur. Here everybody, this is monoclinic sulfur. Monoclinic sulfur, you can see it is stable over 369 kelvins. Below 369, it will again convert into alpha sulfur. So I hope now you understood how the equilibrium is. So इस टेम्परेचर तक आप लेकर आओगे तो रोल सल्फर किस में कन्वर्ट हो रहा है? अल्फा में. और इस टेम्परेचर से आगे जाओगे तो किस में कन्वर्ट हो जाएगा? बीटा में, कंसिडरिंग you will let it fall into this solid form in the crest. Hey guys, have you understood the idea now? What is alpha and beta sulfur?
Yes, I got it.
Right. Next, see what is gamma sulfur. Gamma sulfur is also a monoclinic form, right? This is formed when the hot concentrated sulfur is suddenly chilled in ethanol or CS2 or toluene. Correct. So this form is not very prominently used. Okay. So the gamma sulfur is just this hot concentrated sulfur which is formed. उसको suddenly chill करके ethanol में या CS2 में एकदम से chill कर दोगे तो it will start crystallizing and that will be gamma sulfur. Now alpha, beta, gamma, all sulfurs consist of acid rings and they will have this crown conformation like this. इस तरह से crown conformation में exist करेगा. Clear? And alpha, beta, gamma, all of them are monoclinic forms. अब ये gamma जो beta और gamma का जो monoclinic है, both of them are monoclinic only. Just a bit of layers के arrangement में difference है. So like if we take one such layer, ये W जैसा layer है, ये ऐसा कुछ layering हो रहा है इस तरह से. So that will be gamma sulfur. And this is alpha sulfur. Let me put that here like this. This is like the alpha sulfur, beta sulfur, and if we have layering this way, so there is a difference in the layering here. So then this is called the gamma sulfur. So just the difference in the layering, that's it. But both of them will form monoclinic type only. Okay. Now, this part is only asked for JEE Advanced. So where Engel sulfur or epsilon sulfur is being used. Epsilon sulfur is rhombohedral. Okay. Now this is prepared by pouring Na2S2O3 in hot concentrated HCl and extracting sulfur in toluene. Correct? So if we take Na2S2O3 in HCl in the presence of toluene, then the sulfur will get extracted in the toluene. It will get dissolved in the toluene, and when you remove it out, the toluene will have that sulfur content. And that sulfur is called Engel sulfur or epsilon sulfur. So, this consists of S6 rings. हाँ बेटा.
So नहीं समझ में आया क्या?
Okay, listen. See, Na2S2O3 thiosulfate, if you add it to HCl, okay beta, then this sulfur will get reduced. And one of the sulfur will get oxidized. दो sulfur है ना यहाँ पर. It is disproportionation. +2 से 0 चला जाएगा. एक +2 से +4 चला जाएगा. So it is an redox reaction, disproportionation happening. अब ये सल्फर है, ये वाटर में डिसॉल्व नहीं होता है. इसके लिए हमने टोलिन को एज ए सॉल्वेंट लिया है जिसमें सल्फर डिसॉल्व हो जाता है. So when you remove toluene और water के तो layer ही अलग होते हैं. So if you see those two layers, sulfur will be in the toluene layer and will extract sulfur out of it. Clear बेटा? And अब वो toluene हटा के उसको crystallize करो. Basically कोई भी toluene का solution रहेगा तो उसको आप crystallize करोगे तो मतलब temperature decrease कर दो. As you decrease the temperature, the sulfur will start crystallizing. So the crystallized sulfur will be in the form of S6 rings, and that is in a rhombohedral crystalline form. बेटा समझा?
हाँ सर, ये समझ सर. हमने ऐसे एग्जांपल कभी पहले किया है क्या, जहाँ पे डिफरेंट लेयर्स आ रहे हो?
नहीं बेटा, यही पहली बार कर रहे सल्फर. ये इक्वेशन पहले यूज किया हमने रिडॉक्स में.
ओके सर.
नेक्स्ट, सी दिस इज द ओवरव्यू ऑफ द एक्शन ऑफ सल्फर. ये एक ओवरव्यू लिखा है मैंने, एक बार ओवरव्यू को समझते हैं. ठीक है, इसके ऊपर एक पैराग्राफ बन के आया था जेईई एडवांस में एक बार क्वेश्चन. इसके लिए एक पूरा ओवरव्यू देखना कैसे आया. S8 सॉलिड, ठीक है, रोल सल्फर है, उसको हमने 190 डिग्री सेंटीग्रेड पे हीट किया. सो इट विल फॉर्म इनटू अ मॉल्टन फॉर्म ऑफ सल्फर. इफ यू हीट अप टू 160 डिग्री सेंटीग्रेड, S8 चेन्स विल ब्रेक टू फॉर्म ए डाई रेडिकल. ये एक डाई रेडिकल जैसे बनेंगे. अभी भी ये लिक्विड स्टेट में है, ये डाई रेडिकल जैसे बन रहा है और ये लिक्विड स्टेट में एग्जिस्ट कर रहा है अभी भी. प्लीज अंडरस्टैंड. एंड इफ यू गो फॉर if you keep increasing temperature up to 200 डिग्री सेंटीग्रेड, अब ये जो डाई रेडिकल्स है वो सारे एक दूसरे को बॉन्ड बनाएंगे पॉलीमर जैसे, एंड दैट विल बिकम ए लॉन्ग चेन ऑफ सल्फर एंड दैट विल बी विस्कस. ठीक है, सो 200 डिग्री तक वो एक विस्कस फॉर्म में रह जाएंगे. क्लियर एवरीबॉडी? एंड अगर ये हमने हीट किया, इसको फर्दर 200 डिग्री सेंटीग्रेड पर हमने हीट कर दिया, तो ये जो लॉन्ग चेन ऑफ सल्फर बना है ना, ऐसे सल्फर 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 ऐसे रिंग बन रहा है. नाउ दिस रिंग विल स्टार्ट ब्रेकिंग. क्लियर? और ये कहीं कहीं पे ब्रेक होकर थोड़े से S2 बना देंगे. थोड़े फॉर्म्स, सम ऑफ देम विल फॉर्म S2, सम विल फॉर्म रिंग चेन्स. करेक्ट? ये 4 रिंग, 5 रिंग, 6 रिंग, ऐसे काफी सारे रिंग चेन्स बना. So what happens? Because now the polymer is converting into lot of monomers, now the viscosity will decrease again. वो thickness चला जाएगा. ठीक है? So if you heat above 200 degrees, it will lose out that thickness, viscosity will decrease, it will form into smaller chains and rings. And finally, if you heat up to 444 degrees centigrade, which is the boiling point of sulfur, you'll only have sulfur vapors. And ये sulfur vapors भी ring forms में रहेंगे, S6, S8 rings. Right? So this will be in S6 and S8 ring forms. And if you heat them to 600 degrees, now these ring forms will convert into only S2 gas, which is similar to that of an oxygen. This another statement either. Yeah, S2 will be in the gaseous form just like O2. And you know, O2 में जैसे light blue color आ रहा है when it is becoming when you convert into liquid form, यहाँ पे ये gaseous state में ही blue colored दिखेगा, and that will be paramagnetic. ये क्वेश्चन पूछा गया है S2 is paramagnetic or not, and just like sigma 2px पहले हमने देखा था, sigma 2px and 2py में unpaired इलेक्ट्रॉन है. यहाँ पर sigma 2px1, sorry, pi 2px1 and pi 3py1. Here there would be unpaired electrons in the molecular orbital of S2. Clear beta? And that causes the paramagnetic behavior. Please go through this once again, everybody. Let me summarize again. Simple sulfur, heated, it has undergone into molten form. Again further heated, chains will break and form into di radicals. Again heated up to 200 degrees, chains will form viscous formation by making polymeric bonds. Further heated above 200 degrees centigrade, chains will break, forms into smaller forms, the viscosity decreases. यहाँ पर यही important है, viscosity when it decreases above 200 degrees it will decrease. And finally, when you go up to boiling point, all those chains and rings which are forming, they will form into small rings, S6 and S8 rings, and comes out as vapors. And further heating will give you S2 vapors. Done? See what are the compounds of sulfur. First, hydrogen sulfide, H2s. It is prepared in a lab by acidification of FeS plus dilute HCl. और लैब में ये apparatus यूज करते हैं to prepare H2s, known as Kipp's apparatus. इसका मैकेनिज्म वर्किंग आपको जेई में नहीं है, आपको सिर्फ इतना पता होना चाहिए कि we use Kipp's apparatus to do that. In the Kipp's apparatus, what reaction will happen is this. FeS, when you treat with HCl, HCl को drop by drop add करते हैं FeS में. So then H2s gas has been released. Clear? And that's how it will work. The same thing can be done with, antimony sulfide. And also in Kipp's apparatus, we will get this as SbCl3 and H2s gas evolved. This is the laboratory preparation of H2s. See, H2s is prepared from many other sources, not in syllabus. So we'll stick to its reactions directly. It is colorless. It has rotten egg smell. It is a good reducing agent, which means it can easily form H2S to S. ये easily oxidize हो जाएगा, बाकी सबको reduce कर देगा. So you can see H2 as an oxidizing reaction in सबके पढ़ा है हमने, अभी उल्टा पढ़ रहे हो. H2S when added to K2Cr2O7, it will give a colloidal sulfur form. If you add it with KMnO4 also, it will give colloidal sulfur. In acidic medium, manganese will become Mn+2. Chromium will become Cr+3. X2 here is mainly for chlorine and bromine, not for iodine. Correct? So if you take chlorine and bromine in reaction with H2S, it will give HX and colloidal sulfur will form. Fe+3 is also a good oxidizing agent. It will become FeCl3 and H2S will become S. Ozone is very powerful oxidizing agent. It will convert into S. Peroxide is also oxidizing, convert into S. And SO2 is also oxidizing, converts into S. This is also colloidal form. So you can see sulfur mainly converts into this, colloidal form in most cases. Suppose if there are any salts like cadmium, acetate on reaction with H2S, it will form precipitates. Now this time it will form cadmium sulfate precipitate. Lead, it will form black precipitate. Correct? So salt के साथ react करोगे, most of them will form sulfide precipitates. Okay. So these are the, this is what is acting like a good reducing agent by H2S. I hope all of you understood how H2S is used.
Yes.
Next see, okay. Next see SO2. SO2 preparation is done by burning sulfur. Any form of sulfur, if you burn in the presence of oxygen, it will give SO2 and SO3, while SO2 is a major form of it. Next, see acidification of this. SO3 2- and S2O3 2-. Look at it. Na2S2O3, if you add it to dilute HCl, okay, this form of sulfur, abhi humne learn kiya na, ye wahi wala compound. So some part will convert to SO2, which is getting oxidized, or some part will convert into S, which will getting reduced. And Na2SO3 करोगे तो सिर्फ SO2 आएगा, यहाँ पे सल्फर नहीं है. देखो एक्स्ट्रा जो सल्फर था वो रिड्यूस हो जाएगा उतना ही, बस कुछ नहीं है. यहाँ पर कोई ऑक्सीडेशन रिडक्शन नहीं हो रहा है, यहाँ पे सिंपली NaCl बन रहा है, वाटर एंड SO2 बन रहा है. That's it. FeS2 on reaction with O2 will form Fe2O3 and releases SO2 gas. These are the preparation reactions for SO2. Now see the structure. See beta, SO2 में दो pi bonds होते हैं. One pi bond is coming from 2p pi, 3p pi overlapping, and one is from 2p pi and 3d pi overlapping. So question normally asked is how many p pi bonds are present and how many p pi d pi bonds are present. So in SO2 you can see there is one p pi d pi bond present. Okay. You can clearly observe ये तीनों जाके hybridize होते हैं sp2 and this would participate in pi bond. SO2 is a colorless, pungent odor and suffocating smelling gas, and it will give that suffocating effect. It acts like both oxidizing and reducing because it is at +4 oxidation state. If it acts like reducing agent, it will become SO4 2-. As an oxidizing agent, it will become sulfur. Okay. See first few addition reactions. SO2 plus chlorine in the presence of charcoal, correct, it will give sulfuryl chloride. Okay. So it will take away chlorine and make sulfuryl chloride. The structure of sulfuryl chloride will be like this: Cl with double bond O, double bond O. So the oxidation state is +6 here. So ध्यान रखना sulfuryl chloride with +6 oxidation. So chlorine is getting reduced, sulfur is getting oxidized. SO2 plus half O2 will give you SO3 in vanadium pentoxide. And SO2 plus PbO2 will also be written as PbO plus SO2 plus O will become SO3. ठीक है? और ये PbO plus SO3 will become PbSO4. So hence it will appear like a precipitate as PbSO4. Okay. Now see, SO2 can also act like a bleaching agent due to its reducing behavior. Okay. So you can see it acts like a bleach in the presence of moisture. So you can see SO2 will take oxygen. I mean, in the presence of oxygen and water, it will try to become SO3 and releases this nascent oxygen. Here. And again, if you take that SO3 gas, suppose if SO3 gas comes again in contact with the nascent hydrogen, it will convert back to SO2 plus H2O. Alright? Convert back to SO2 and H2O. So whenever the bleaching is happening due to nascent hydrogen, that is always called as a temporary bleach. Okay. This is used by magicians. They will write something on the paper, correct? And pehle, if you react it with SO2, वो पूरा colorless बन जाएगा, correct? Again, if you bring it back to any hydrogen gas or any nascent hydrogen का कोई salt डाल दोगे, right? मतलब maybe something like something like zinc in HCl आप डाल दोगे तो nascent hydrogen आएगा. And as soon as that comes into account, again SO3 will react to give back that color. So that's why it is used as the temporary or a nascent temporary bleaching for via nascent hydrogen. Okay. Let's see how SO3 is prepared and what are its uses. SO2 plus O2 in the presence of vanadium pentoxide will give SO3, and this is what we call it as contact process. Structurally, we have this as SO3 with sulfur being sp2 hybridized. Out of these 3 pi bonds, 1 pi bond is p pi and 2 pi bonds are p pi d pi bonds. SO3 can exist in different forms depending upon the pressure applied. गैस के ऊपर अगर प्रेशर अप्लाई करोगे तो वो साइक्लिक फॉर्म में या पॉलीमरिक फॉर्म में बन जाता है. The cyclic form of sulfur, correct, where it is forming tricycle here like this, that is called the gamma sulfur or sulfur trioxide. Here. Next, if it is forming a linear form like this, SO3 का एक linear form बनता है, so then that is called beta sulfur trioxide. That is beta sulfur. And if the same beta trioxide is making a cross links, यहाँ पे ऐसे cross links बना देता है in the linear polymer, then that is called alpha sulfur. So उल्टा देखना बेटा, complete cross links रहेगा sulfur के, so that is alpha. If it is only straight chains, that is beta, and if it is cyclic, that is gamma sulfur trioxide. Clear with the solid forms, everybody?
Yes.
This has been asked only. If you see from JEE, in so many years, I have seen one question asked on this: how cyclic form of sulfur looks like. I mean, sulfur trioxide looks like. Okay. ऐसे questions दिए कि how many number of SOS bonds are formed. Clear? What is the type of cycle which forms? Next. SO3 is an oxidizing agent. So it can oxidize, something like HBr to Br2 and P4 to H3 P4O10. Okay. So you can see SO3 hot can be added to HBr to give Br2 plus SO2. And SO3 plus P4 will get oxidized and sulfur will get reduced. Okay. These are few oxidizing reactions of SO3. See SOCl2. देखो NCERT यहाँ तक खत्म. इसके ऊपर NCERT में कुछ नहीं है. This is extra information which is definitely needed for us because ये organic में भी आ जाता है. Okay. See SOCl2, thionyl chloride, PCl5. If you treat with SO2, it will become POCl3 plus SOCl2. Reaction wise, if you look at it, think like this ना. PCl5 में क्या होगा, हमेशा एक ऑक्सीजन ले लेगा ये. ठीक है, एक ऑक्सीजन ले लिया तो उसके बदले में 2 क्लोरीन दे दिए तो क्या बन जाएगा, SOCl2 बन जाएगा, ये POCl3 बन जाएगा. So SOCl2 on hydrolysis will become H2SO3 and on warming that you'll get SO2 gas out. And SOCl2 in basic medium, it will become a salt, Na2H2O3, because this is an acidic oxide form and gives away HCl. Okay. Mechanism wise, if you look at it, OH minus will attack on sulfur, removing chlorine. So we'll get 2 OH groups on it. This is sulfuric acid. In basic medium, it will take away this 2 H plus and become sulfite ion. Okay. Next. We have seen these reactions earlier, that alcohol in the presence of SOCl2 will give alkyl halide, gives away SO2 and HCl via SNI mechanism. Acids with SOCl2 will also remove this OH, replace that with chlorine and gives SO2 and HCl. P4 with SOCl2 will make it PCl3, correct, and becomes SO2 and S2Cl2. यहाँ पे ये याद रखना, this is becoming S2Cl2. आगे ये रिएक्शन फिर से आएगा जहां पर SCl2 बन रहा है. So इसके लिए अभी से ये दोनों का डिफरेंस समझना. This will become S2Cl2. Now what we discussed is thionyl chloride beta. When you have only one oxygen, then SOCl2 formation is called thionyl chloride. If we have 2 oxygens, then it will form SO2Cl2, which is sulfuryl chloride. It is called sulfuryl chloride. So SO2 plus Cl2 is forming SO2Cl2 and PCl5. देखो मैंने बताया था, यहाँ से ऑक्सीजन एक चला जाएगा, यहाँ से 2 क्लोरीन एक्सचेंज हो जाएंगे. So you'll get POCl3 and SO2Cl2. That's it. So दोनों का प्रिपरेशन ना बिल्कुल सेम है, इससे पहले का और इसका. Okay. Next, reaction wise, if you look at it, SO2Cl2, if you treat with H2O, it will undergo hydrolysis to give sulfuric acid and HCl. And SO2Cl2 in basic medium will form Na2SO4 plus NaCl. Correct. Next, if you see alkanes in the presence of SO2Cl2, हम लोग इसको यूज करते हैं for making chlorine substitutions, correct? And this is known as Reed's reaction, free radical mechanism. देखो यहाँ पे मैंने नीचे mechanism लिखा है in case if you don't remember. SO2Cl2 in the presence of H nu will form these two radicals, SO2Cl and Cl radicals. The Cl radical will attack on alkane to form R dot and HCl. Okay. This R dot will further react with SO2Cl to give RCl and SO2. When you want to make, normally हम लोग chlorination करते हैं. If we do chlorination, we do not usually get, tertiary as major. We'll always get all the mixtures. Correct? We always get the mixtures. Like secondary भी आएगा, primary भी आएगा, tertiary भी आएगा. Correct? But in Reed's reaction, we can get distinctly very high composition of tertiary chloride. Okay, that's why we use Reed's reaction for chloro substitution. Clear, everyone? Next, this is the reaction I told you. P4 plus SO2Cl2 will become, earlier it was becoming PCl3, now it will become PCl5. So PCl5 plus SO2. Done, everybody?
Yes, sir.
Next. The last thing about this chapter is more about oxoacids. How to see oxoacids. These are the various oxoacids which are formed by sulfur. एक को ध्यान से समझना terms के साथ. Sulfurous. The minute we are using us acid, the oxidation state can be 4 or less than 4. Okay. And आगे पीछे कुछ भी नहीं है, us के prefix में कुछ भी नहीं है, and if it's simply sulfurous acid, it is a +4 oxidation state, and the formula is H2SO3. The structure is simple, S double bond of OH and OH. This is sulfurous acid. Now, pyrosulfurous acid means H2SO4 को आप 2 moles लेकर water हटा दो. So if I take 2 moles and remove water out of it, like these 2 moles I have taken, then you will get H2SO5. In H2SO5, the structure is very, very, very important. The structure is very important, pyrosulfurous acid, because one part of the sulfur here is +5 oxidation state. This one is +5 oxidation state, and the other sulfur is +3. Remember, there is no SOS bond. Usually यहाँ पे confusion होता है बच्चों को कि they will think symmetrically SOS bond मिल जाएगा, and यहाँ पे sulfur का एक double bond, इधर एक double bond. This is not that characteristic which is observed. Okay, इस JEE में बहुत बार आ चुका है. Is there any SOS bond between H2S2O5? No SOS bond. Okay, it is only S and S connection. Next, thiosulfurous acid. Thiosulfurous acid, as in we have S and S bond, correct? And we have sulfurous. As मतलब +4 के नीचे ही होना चाहिए, +4 या +4 के नीचे. So S and S bond will always give you thio. ये thio use word use कर रहे हैं whenever for sulfurs, which means we have S and S bonds, correct? And here we have double bond OOH and double bond OOH here. Oxidation state +3 here and +3 here. No SOS bond in this case also. Next, sulfuric acid, H2SO4. And this is the structure we know. +6 is the oxidation state. Because it is +6, matlab anything more than +4 is ic acid. That's why it is sulfuric acid. Next, thiosulfuric acid. Thiosulfuric means H2S2O3. Here, this sulfur and this sulfur are connected. That's why it is thio. Now, remember this. Here, this oxygen is being replaced. Sulfuric acid में से ये जो oxygen था, that oxygen is being replaced by sulfur. That's it. But the properties of this oxygen will retain here, which means the oxidation state of this sulfur is still going to be -2, and this sulfur is going to be +6. So यहाँ पे oxidation states important है. Like what is the oxidation state of thiosulfuric acid? Okay. Next, oleum or pyrosulfuric acid. Pyrosulfuric acid is formed when you take H2, S2, H2SO4 and add excess amount of SO3. We add that, we call it as the oleum labeling or percentage oleum. If we add that, we'll get this as H2S2O7. Here there is an SOS bond in between them. So oleum will have SOS bond. Oxidation state in both the sulfurs are +6. Got it.
Oleum का
Next,
alkyl halide में भी
dithios-
reaction था ना sir?
क्या बेटा?
Oleum was used as an intermediate or something in alkyl halides as well, na sir? I remember reading in
Benzene.
बता सकते हो?
Benzene
अच्छा
में
सर, reaction क्या था सर?
सर वो सल्फोनेशन में कुछ था।
हाँ सर, भाई को बता सकते हो क्या?
Benzene in the presence of oleum and heat will give us SO3H. Okay. Sulfonation. Clear beta? Next.
Yes sir, thank you.
Dithionic acid. Dithionic acid again will not have SOS bond. Thio word use किया हमने, SS bond को represent करना पड़ेगा इधर. And we have OH and OH, H2S2O6 here. So it is +5 oxidation state on both the sulfurs. So again, oxidation state is more important here. Okay. अब देखो बेटा, thionic acid can be used based upon number of sulfurs here. तो अगर कभी गलती से ऐसा दे दिया tetrathionic acid, if this is been given, okay, the structure would be same, H2S4O6, मतलब OH सेम ही रहेंगे, इनके बीच में सल्फर के बॉन्ड्स बढ़ते जाएंगे उतना ही, इस तरह से. क्लियर? डबल बॉन्ड O, डबल बॉन्ड O, डबल बॉन्ड O, डबल बॉन्ड O, OH. So I hope you got the rhythm now. So this would become tetrathionic acid. अगर pentathionic acid पूछा तो क्या करोगे बेटा? बीच में 3 सल्फर रखोगे. हेक्सा मतलब 4 सल्फर रखोगे, बस. So आइडिया क्लियर है ना? बस ये सल्फर और ये सल्फर के ऑक्सीडेशन स्टेट्स रहेंगे +5 एंड +5, बाकी सारे सल्फर्स के होंगे 0. That is how the oxidation states would be. Okay. Next. See, monoperoxy sulfuric acid. The common name is also known as Carrot's acid. We have learned this in redox reaction. H2SO5 will have one peroxy linkage, with it, but the oxidation state of sulfur is +6. Peroxy disulfuric acid, also known as the Marshall's acid, which is H2S2O8, where sulfur is connected with peroxy linkage. Oxidation state is still +6. Okay. This I would suggest strictly beta लिख के practice करो. Okay. These 9 पहले पढ़ना, फिर बिना देखे लिख देना सबको. सिर्फ आप एक बार फॉर्मूला सामने रखो, सारे फॉर्मूलास एक बार रखो और ट्राई करो स्ट्रक्चर बनाने का और ऑक्सीडेशन स्टेट बनाने का. ओके. डू द सेम थिंग फॉर फॉस्फोरिक एसिड. बिलीव मी, इट इज वन श्योर शॉट क्वेश्चन. ओके. फॉस्फोरिक एसिड एंड सल्फ्यूरिक एसिड से एक क्वेश्चन पक्का आता है हर साल. तो ये जो लिस्ट पहले फॉस्फोरिक एसिड का मैंने इससे पहले दिया है, वो टेबल में है, वहां पे 6 एसिड्स है, यहाँ पर 9 एसिड्स है. Okay. Next, the last thing we will study is about the sulfuric acid, also known as the king of chemicals. See, first preparation is by contact process. Process बहुत easy है prepare करना. Any form of sulfur burning with oxygen will give SO2. SO2 in the presence of O2 and vanadium pentoxide will give SO3. And क्योंकि यहाँ पे ये गैस but ये solid है, this is one of the examples of heterogeneous catalysis in surface chemistry. We have used this as one of the examples for heterogeneous catalysis. Yeah? होमोजेनियस कैटालिसिस में क्या होना चाहिए? ये भी गैस गैस, ये भी गैस होना चाहिए, ये भी गैस होना चाहिए, तो देन वी से इट इज हेटेरोजेनियस कैटालिसिस, आई मीन सॉरी होमोजेनियस कैटालिसिस. सी फर्स्ट वी गेट SO3. SO3 को वाटर में ऐड करोगे तो H2SO4 आ जाएगा. बट H2SO4 इज नॉर्मली फ्यूमिंग. ये सब in NCERT there is a proper industrial diagram given. H2SO4 fuming बन रहा है, and this H2SO4 fuming means it will keep, oxidizing, it will keep going back towards SO3 gas formation. So उसको रोकना है हमको. So what we do, we add excess amount of SO3, and excess amount of SO3 which you add will create it as oleum, and oleum is very stable thick solution, and that's how we store the acid. Correct? And when you want to recreate acid, you add the proportional amount of H2O to form H2SO4. This is done via labeling of oleum, which we have learned in redox. Okay. So oleum labeling use करके हम लोग H2SO4 बनाते हैं. Correct? This is about contact process. Now see what is lead chamber process. Sulfur plus O2 is giving SO2. Now SO2 plus O2, if you react, you will get SO3 in the presence of NO2 beta. अब देखना, gas, gas, gas and gas. That's why it is one of the good examples of homogeneous catalysis. Students, tell me, formation of ammonia, is it an example of homogeneous catalysis or heterogeneous catalysis? Haber process.
Heterogeneous.
Correct, heterogeneous. Why beta?
Sir, FeMO.
Iron and MO use करते हैं ना हम लोग. Iron is used as a catalyst, molybdenum is used as a promoter. Okay, और दोनों ही solids है. Clear? Right. See the mechanism. SO2 reacts with NO2 to become SO3, and NO2 will get oxidized to, reduced to NO. And this NO again reacts with O2 to form NO2. So overall reaction is SO2 plus O2 giving SO3. That's how NO2 is acting like a catalyst. Okay. Once you get SO3, you take that SO3, add it with some H2SO4, you will get oleum, and that's how we can prepare H2SO4. Correct? Hydrolyze करोगे तो फिर से H2SO4 आ जाएगा. The last step. Okay. See the properties. H2SO4 is a colorless, odorless, and oily liquid. It is viscous and have high boiling point because of strong hydrogen bonding. Correct? It is dibasic acid. The first giving H plus is very easy for the first reaction. So Ka1 value is very large, greater than, it is normally greater than 10 raised to power of 8. Next, HSO4 minus, in case if you take some salt of HSO4 minus, that will give you H plus, and Ka2 is reasonable, 10 raised to power of -2, which is reasonable, not very low also, not very high also. Okay. Clear? Next, see the reactions. H2SO4 main reactions are beta dehydrating agents. It is used as dehydrating agent. If you take formic acid, इसमें से water हटा दो, so OH and H, so we left with carbon monoxide and water. Oxalic acid, water हटा दो, H2O and O निकाल दो, so we'll get CO plus CO2. Glucose में से water हटा दो, so we'll get only carbon present. So this is called chairing of glucose or sugar. So we'll get a black color carbon here. So this is a black color, carbon which is formed when we add concentrated H2SO4. Clear? Next, action of salt. If we take NaCl, and treat with concentrated H2SO4, okay, it will form HCl vapors and HF will be formed. There are two important things. One, it cannot form Cl2 because chlorine's reduction potential is high. So Cl2 can form Cl minus, but Cl minus forming Cl2 is not easy with H2SO4. Okay. And same thing, F2 can form F minus, but from here to here, not possible. Hence, and both of them are volatile enough to come out as gases. Okay. HCl as well as HF are volatile enough to come out as gases. While HBr cannot come out as gas, HI cannot come out as gas. Therefore, gases की तरह नहीं आ पाएंगे तो major product oxidation reduction ही होगा. So this time Br minus will undergo oxidation to give Br2. I minus will undergo oxidation to give I2. So the reactions with this halide salts is important. So chloride and fluoride only give vapors of acids, while bromide and iodide will oxidize to bromine and iodine. Here everybody. And see, non-metals के साथ reaction. If you take concentrated H2SO4 with carbon, it will become carbon dioxide plus SO2 plus H2O. Okay. And sulfur, if you treat with concentrated H2SO4, it will become sulfur dioxide plus H2O. Correct? So these are the reactions with non-metals, which is undergoing oxidation and reduction. And then see metals. If we talk about metals, zinc, if you treat with dilute H2SO4, it will form ZnSO4 plus H2. Okay. And then if you treat with concentrated H2SO4, ये oxidation reduction, redox reaction ज़्यादा करेगा rather than acid base. So concentrated H2SO4 will become ZnSO4, SO2 plus H2O. यहाँ पे भी redox बन रहा है, but H2 gas मिलेगा, यहाँ पर SO2 मिलेगा. You know, copper does not dissolve in dilute H2SO4 because the reduction potential of copper, okay, is greater than reduction potential of H2. Hence, no reaction. But if you react with concentrated H2SO4, all of this copper, silver, mercury, correct, they will all become sulfates and SO2 will get formed. मतलब ये खुद reduce हो जाएगा SO2. Guys, have you understood that? Everybody? Here?
Yes.
Right. That's it, beta. These are the reactions of H2SO4 from sulfur. Okay. So sulfur mein main, if you ask me, right, oxygen mein, this is the main part. Okay. So learn about these acids and their structures. लिख के learn करो उसको. बाकी सब बहुत shady है, बहुत ज़्यादा पूछा नहीं गया. एक कोई structurally ये थोड़ा कभी पूछा गया JEE में. And other than that, this properties of H2S, how the reactions happen for H2S. Okay. And this is strictly for advanced, this entire concept of, heating for sulfur. So if you get sufficient time, just go through this, walk through this. This is all given in JD Lee also, if anybody wants to refer. I've taken reference from there only. So आपको अगर बहुत detail में पढ़ना है, तो you can just read once what is given in JD Lee. That's it. Okay.